In section 1.4, we will talk about solving right triangles. Now, in this case, the first case, we'll be solving right triangles given an angle. Okay, so here are the steps. Step one, for the given angle, label each side as opposite, adjacent, hypotenuse. This is super important. Make sure you label each side. Then remember that sine relates opposite over hypotenuse, cosine relates adjacent over hypotenuse, and tangent relates opposite over adjacent. Then solve for the missing side. All right, so let's take a look at this first example. We're given this angle is 53 degrees. Now, our first step is to label each side as the opposite, adjacent, hypotenuse. I'll start with the hypotenuse. That's a diagonal across from the right angle. So this is the hypotenuse. Remember that the adjacent side is one attached to the angle. So this horizontal side is the adjacent side. And then directly across from it is x, which is the opposite side. Now, let's look at what is given and what we're solving for. So we're given the hypotenuse, which is 15, and we're solving for x. So the two relevant sides, right now we don't care about this one, the two relevant sides are the opposite and the hypotenuse. So let's think about which function relates the opposite and the hypotenuse. And that's going to be the sine function. Sine relates opposite and hypotenuse. So we're going to say the sine of 53 degrees equals to the opposite, which is x, divided by the hypotenuse, which is 15. Now to solve for x, the x is being divided by 15, so the inverse of division is multiplication. So we will multiply both sides by 15. So on this side, we get x by itself. And on the other side, we have 15 times the sine of 53 degrees. And if you put this in a calculator, that's going to round to 11.980. Remember to use 3 decimals. Let's take a look at another example. So we're given this angle, and now I'm not going to label all the sides. I'm just going to label the side that's given and the side that we're solving for. So the given side is 15, and this is the hypotenuse. Now, in relation to 30 degrees, x is attached to it, so x is going to be the adjacent side. And we don't care about the opposite because it's not given and we're not solving for it. So adjacent over hypotenuse is related, so if you look at SOHCAHTOA, adjacent over hypotenuse is related by the cosine function. So we're going to say cosine of 30 degrees equals to the adjacent side, which is x, divided by the hypotenuse, which is 15. And once again, to solve for x, the x is being divided by 15, so the inverse of that is to multiply by 15. And the 15s cross out, and we're going to get x equals to 15 times the cosine of 30 degrees, which is going to be 12.990. Another thing that I forgot to mention is that make sure your calculator is in degree mode since we're working in degrees. All right, so this next example, we're solving for x and for y, and this one we will do in class. Okay, next example, we're solving for this missing side, x. So let's take 67 degrees. This is the given angle. And let's label all the sides. So the hypotenuse is missing, but I'm going to label it anyway. The attached side to 67 degrees is going to be its adjacent side, and directly across from it is going to be its opposite side. So now, what are we solving for? We're solving for the opposite side, and we're given the adjacent side. So in SOHCAHTOA, let's think about which function relates the opposite and the adjacent, because that's what's missing. For adjacent is what's given, opposite over adjacent. That is going to be the tangent function. So we're going to say that tangent of 67 degrees is equal to opposite, which is x, divided by the adjacent, which is 14. Now the x is being divided by 14, so the inverse of that is to multiply by 14. And the 14s cross out. In your calculator, you're going to put tangent of 67 degrees times x, and the answer to that is going to be 32.982. All right, now let's go to the second case. So what if we're solving triangles for an angle and we're given the sides? So we're given sides and we're looking for a specific angle. Well, what are the steps? Step one, for the missing angle, label each side as opposite, adjacent, hypotenuse. Notice that this is important each time. Determine which function relates the missing angle to the sides. So we're looking at SOHCAHTOA. And then finally, solve for the angle by taking the inverse function of each side. We'll talk about this step once we get there. So in this case, we're solving for angle B. We're looking for this angle here. So let's label everything in relation to angle B. We know that this is the hypotenuse. 7 inches, this side is related, this is connected to angle B, so this is going to be its adjacent, and then 4 inches is across from it, and so this is going to be its opposite. So the hypotenuse is irrelevant because we're looking at the two given sides, opposite and adjacent. The function that relates opposite and adjacent is going to be tangent. So we're going to say that tangent of angle B, or tangent of B, is equal to the opposite, which is 4, divided by the adjacent, which is 7. Now, how do you solve for B? Well, we need to get rid of the tangent. And in order to get rid of the tangent, we're going to use the inverse tangent function. So what we're going to do is we're going to take the inverse tangent of the left side, which is tangent B. And you can find the inverse tangent in your calculator. Most often, it will be above tangent, but you'll have to look at your specific calculator to figure out where that is. And then whatever we do to the left side, you have to do to the right side. So to the right side, we do the exact same thing. We're going to take the inverse tangent of the right side, which is 4 over 7. Now, an inverse tangent and tangent, they undo each other, and we're left with B, which is our objective. Now, in your calculator, put in inverse tangent of 4 over 7. Make sure that you use parentheses for 4 over 7. Okay, use parentheses for 4 over 7. For most fractions, you should be using parentheses. And so if you take the inverse tangent of 4 over 7, this will give you 29.745 degrees. Okay, let's take a look at the next example. We are given angle X, and our first step is going to be to label each side with respective to angle X. Okay, so first thing I want to do is label the hypotenuse as across from the right angle. That's my diagonal. This is the hypotenuse. Now the side connected to angle X, the 109, that is going to be the adjacent side, and then across from it is going to be the opposite side. The opposite side we don't care about because we're given the adjacent and the hypotenuse. So in SOHCAHTOA, we have to think about which function relates the adjacent and the hypotenuse, and that's going to be the cosine function. So I'm going to say that cosine of x equals to the adjacent, which is 109, divided by the hypotenuse, which is 134. Now, once again, we have to take the inverse of each side. So if we take the inverse of the left side, we're going to get inverse cosine of cos x. And then whatever I do to the left, I have to do to the right. So I take the inverse cosine of the right side also, which is 109 over 134. Now the inverse cosine and cosine, they undo each other, And then on the right side, we take the inverse cosine of 109 over 134, and that's going to be 35.567 degrees. Now this next example we will do in class. Our next topic is going to be the angle of elevation and angle of depression. So the angle of elevation is the angle between the horizontal line of sight and the line of sight up to an object. So let's say you're standing here. This is the horizontal line of sight, and then this is the line of sight to the top of an object. So this is going to be your angle of elevation here. And your angle of depression is the angle between the horizontal line of sight and the line of sight looking down at an object. So the angle of depression is going to be this one. Now, if you think back to geometry, these are called alternate interior angles. So when you have two parallel lines, the angles on the inside of a transversal are called alternate interior angles, and alternate interior angles are equal. So in this case, the angle of elevation will equal to the angle of depression. So here's an example. It says the angle of elevation to the top of a building in New York is found to be 8 degrees from the ground at a distance of 1 mile from the base of the building. First thing we should do is we should draw this. Okay, so here we have a building. So this is our building. And the angle of elevation to the top of the building is found 8 degrees from the ground distance of 1 mile. So this here is a distance of 1 mile. And if you're looking up at the building, that angle of elevation is 8 degrees. Using this information, find the height of the building. Now it says in feet and round to the tenths, the nearest tenths. So first off, because we want the answer in feet, we're going to say that 1 mile is equal to 5,880 feet. Let's rewrite that. We're looking for the building, which we're going to call x, and we're given this angle 8 degrees. So let's label this in terms of the angle that's given, in terms of 8 degrees. So the hypotenuse is going to be the diagonal, but we don't really care about that because that has nothing to do with the problem. The side connected to 8 degrees is the ground distance, which is going to be the adjacent side. And across from that is the building, so that's going to be the opposite side. So now let's think about which function relates the opposite and the adjacent. So we have SOHCAHTOA, and the tangent function relates the opposite and the adjacent sides. So we are going to say that tangent of 8 degrees equals to the opposite, which is x, divided by the adjacent. And again, we don't want to use 1 mile because we want the answer in feet, so we're going to use 5,880 feet. If you want to solve for x, the inverse of dividing by 5280 is going to be to multiply by 5280. So we're going to get x equals to a tangent of 8 degrees times 5280, which is going to be 742.1 feet. And now it says here round to the nearest tenths, which means 1 decimal. So normally we round to 3, but because it specifies 1 decimal, this is going to be 742.1. And don't forget the units. Anytime there are units, you should always use them, feet. The next problem, we're going to set it up a little bit, and then we'll work it out in class. So it says to estimate the height of a building, 2 students find the angle of elevation from a point at ground level to the top of the building is 37 degrees. So here's your building. And the angle of elevation to the top of the building is going to be 37 degrees. Now, what they do is from a point that's 300 feet closer, so they're going to move 300 feet closer, And that new angle of elevation is going to be 59 degrees. And we'll leave it at that.